Hello there and welcome to this CS Watch video 004 where we're looking at unreliable systems. Before we get underway, make sure you've watched video 003, the link of which you can see below, which gives you background information on reliability. If you've previously watched that, fantastic, let's get going. If you've not watched that, click pause, open up a new tab, have a quick watch, then come back to this video here. So let's get going at looking at unreliable systems. So, we're looking at three unreliable systems in today's video. The first one we can see here is the NHS IT system, and you can see some of the facts appeared on your screen before you. The cost to the taxpayer is over £10 billion, with the original expected cost to be around £6.4 billion, so you can see that's quite an overspend. When this system was first developed, it was a fantastic idea, it was a fantastic concept. Doctors, GPs, nurses, all NHS stakeholders being able to access data from the same IT system. The data presented in the same way and the data accessed in the same way, which meant different surgeries, different doctors across the country had one uniform way of doing it. Had the added advantage, so for example if a nurse worked in New Haven, they could go over, use the same IT system in Eastbourne straight away without having to have any prior training or working out how to use it. However, there were multiple issues involved in the creation of this system. Different doctors, different surgeries, different nurses all stored and used data in very different ways. Some stored it inside a spreadsheet, some of them in a database, some on a pen and paper file system, very old school. There is an extremely tight timescale. Some people seem to think that creating complex systems such as this can be done by one person sat in their basement over the course of a few weeks. Unfortunately, that's not the case. There's multiple systems which needed bringing together. Everyone had their own idea on how they should store their data and what is the best way to store their data. So again, that all needed looking at. Different stakeholders, so for example doctors, surgeries, the management of NHS Trust had very different priorities and expectations from what they wanted from the system, and because none of them really talked to each other, that led to the system failing. We're now going to look at the Royal Bank of Scotland software update. What happened with this is people's bank accounts were effectively frozen because they weren't able to access for them, some customers for up to 2 weeks. In missed payments for mortgages and credit cards and general day-to-day banking, it cost RBS £125 million. Customers for RBS as well were left unable to make or process payments, which meant people went out not being able to do their food shopping, fill up their car, or do anything which involved their bank account. The kicker for this as well for RBS is that whatever went wrong, it could only be fixed manually. So someone had to go into their systems, change their code line by line to make sure everything could get working again. The final system we're looking at is the Ministry of Defence Recruitment Hardware. What this was designed for is to allow up to 1,000 soldiers to return to frontline duty from wherever they were. Again, like the NHS IT system, it was a fantastic idea. It was a really good thing to have around. But, as with other complex IT systems like this, it got hit by delays, it got hit by bugs, and the cost of the system was £1.3 billion. When it was behind schedule, it cost the Ministry of Defence £1 million a month just to keep things up to date, just to keep things going. So again, we're looking at another IT system which has had costly failure. So we've got here a nice exam question. Feel free to click pause and give it a go. And here we go, there's some answers for you. I hope you've enjoyed this video. Feel free to like, comment and subscribe, and I'll see you in a future video. Goodbye.